All right. So this is what I got, guys. I got chapter 2 on day 2 notes for today. We're going to work on goal number 3, which is form the sum, difference, product, and quotient of two functions. Okay. So you're going to see something like this where it's f plus g, or you might see it where it's f plus g of x like that. And don't freak out. All you're doing is you're going to take the two functions f of x and g of x, and you're going to add them together. Okay. So same thing if you see f minus g, or something like this, f minus g of x, we're just going to take the two functions f of x and subtract g of x. Same thing with this one. If you see f times g, a little dot is multiplication, as you guys know. You could see an x on the outside. That's just the same thing as f of x, and then multiply it to g of x. That might involve foiling. It might involve distributing. I don't know. You got to see what you got to do. Okay. F divided by g, that's just taking f of x and dividing by g of x. And that's actually one of the easiest ones to do when you're just taking the two functions and putting them over each other. Okay. There's going to be some evaluating that we have to do, and there's going to be some talking about domain, which we talked about last time I saw you on Friday. So you'll see that stuff again. Okay. All right. So let's dive in. Do you have any questions? So I'm using these two functions here. I've got on examples. It's just f of x divided by g of x. You're just taking the f of x and then g of x is your denominator. That's all. All right, guys, so these are the two functions I got. I got the square root of x is f of x, and g of x is just 3x plus 5. I'm going to do f of x in blue here, and then g of x I got in red. Okay? So the first one they have is what's f plus g of x? And if you want to, you can just rewrite it. You don't have to. All you're doing is you're taking f of x plus g of x. Okay? Well, f of x is the square root of x, and then g of x is 3x. Let me rewrite this here. I'm trying to use fancy colors. Well, then g of x is 3x plus 5. So in this step, I would add and subtract my like terms, but as you can see, there's no terms that are similar. So that is my final answer for f plus g of x. There's no simplifying that I can do here, so I just leave it alone. Okay. Now, domain. We talk about domain, and they're asking us to also find the domain of this one. We talk about domain with square roots. What values can we not square root? So this is from Friday. What values can we not square root? Where do I get a error message in my calculator? Connor, Ryan, Jose, Chris, Duncan, Madeline. What can we not square root, y'all? Negative. We can't do negative. So whatever's underneath has got to be greater than or equal to 0. Okay, so when we're talking about my domain is the set of all real numbers such that x has got to be greater than or equal to 0. Okay, so that means greater than 0, the positive numbers, and then equal to 0 is 0. I can take the square root of 0, I get 0, that's fine. I can take the square root of any positive number and get a number back. Totally fine, no worries. Okay, so again, I have a square root, there's a restriction in my domain. All right, now if we're asked to evaluate, I'm going to work my way down. If they ask me to evaluate f plus g of 3, well, all we got to do is take f plus g of x, this guy, and then plug it in. Anywhere you guys see a x, we are going to put in parentheses, and in that parentheses, I'm going to plug in this value. So that value is a 3, I'm going to plug in 3. And then we simplify. Square root of 3 is the square root of 3. That doesn't simplify at all. And then 3 times 3 is 9, right? Plus 5 is 14. Okay. So if they want an exact value, this is what my math lab's looking for. It's root 3 plus 14 or 14 plus root 3. Either one they should accept. If they want an approximation, this is where I'd plug in the square root of 3 in my calculator. I would get like 1.73, and then add 14, it would be like 15.73. So you got to see what my math lab's willing to accept.
What do you mean by the approximation?
What's that? Approximation is like using decimals. Right? This is an exact, right? And then if I was to plug this in my calculator, that's the approximation, the decimal. So you got to see. It'll give you 15.73 approximately. Yep. Okay. Guys have any questions? Good question. So as I go through, then we go on to do f minus g of x for the next one. So kind of working our way over. Well, again, all we're doing is we're taking f of x and we're going to subtract g of x. Well, f of x is the square root of x from this guy. And g of x is 3x plus 5. So I want to subtract the whole thing. Now where people get mixed up is they will subtract the 3x, but they forget to subtract the 5. You have to distribute the negative to both terms. Or if you have 3 or 4 terms, you have to distribute the negative to everything. So you're subtracting both of them. Okay, and that's all I got. That's f minus g of x. There's nothing I can combine. There's no like terms there. It is what it is. Final answer. So the big idea is if this is an x, my answer is going to have an x in it. And if this is a number, then I should get a number when I'm all done. All right? So I've got the next one, example 2b, I got 4 minus g of 4. All I got to do is plug in 4 into this guy here. So I just rewrite it like I see it, but instead of x, now I'm going to throw in 4. So far, so good. Please excuse my dear Aunt Sally as we're plugging in. Square root of 4, you all know is what? 2. Negative 3 times 4 is negative 12, and then minus 5. So 2 minus 12 is what? Negative 10. Negative 10 minus 5 is negative 15. And that's it. How we doing, y'all? Questions, comments, concerns? We're okay. All right, so we've taken care of addition, we've taken care of subtraction. I'll tell you, subtraction is the most commonly missed one out of all 4 of these. Addition, subtraction, multiplication, division. This one's missed the most, okay? Now, we didn't talk about domain for this one because the domain of this one and the other one are exactly the same. So the domain of this one is also greater than or equal to 0, okay? There's only a restriction of the square root. All right, I'm moving on to the next one. I'm doing multiplication. So I've got f times g of x. Okay, so it's just f of x. This is how you really write it. And I actually prefer if your textbook would write it because some people get confused on what to do with this x. It's just f of x times g of x. Don't add in like an extra x here. It's just the square root of x and then times 3x plus 5. Taking this guy right up here. So f of x is the square root of x, g of x is 3x plus 5. I'm just multiplying them together. Well, what do you got to do here? How do you simplify this? What's that property called? What do you got? John, what's that property? Troy, McKelvey, Caitlin, Lisa, Jen, Morgan, Sydney. What's that property called? What do we got to do? Yeah. Fantastic. Go ahead and distribute that thing. So I got root x times 3x. That's just 3x root x. And then root x times 5 is just 5 root x. All right. So when we're multiplying, it's 1 times 3x. It's 3x on the outside, then root x times itself, or root x is just x, root x. Okay, so when you multiply, you're really just putting that number in front. That's all. Now, the next one is evaluate f times g of 2. Well, this is f of g of x. It's in terms of x. Now we want to take all those x's and replace them with 2's. So f times g of 2 looks like this, 3. And instead of x, I've got a 2 there, a 2 there, and a 2 there. So far, so good. We simplify. 3 times 2 is 6, root 2, plus 5 root 2. Well, how many root 2's do you guys got now? What's 6 root 2 plus 5 root 2? What do we get? What's 6x plus 5x? What's 6 root 2 plus 5 root 2?
11 root 2.
There you go. Easy peasy lemon squeezy. Yeah, buddy. Boom. Now, the nice thing is a lot of times the domain's the same. We talk about the domain. The domain, again, has got that same restriction. It's got to be greater than or equal to 0. We can't have negatives underneath here. Okay, so domain would be the same. Last but not least is division. So division, super easy. I've got f of x, and I'm going to divide it by g of x. Okay? So I've got f of x is the square root of x, divided by g of x, which is 3x plus 5. There's no factoring, reducing that I can do. If I could do that, I would try to do that. But there's nothing I can reduce here, so it is what it is. The tricky one is to double check your domain to make sure you have your domain. So domain, it's got two things going on here. First thing is that what we talked about, square roots can't be negative. So domain is the set of all real numbers such that x is greater than or equal to 0. That takes care of this one. That takes care of that guy. But then we got to look out for the bottom. We got a denominator, right? We got this 3x plus 5 for the domain. Well, when we have a domain, a denominator, we are worried that the denominator could be what? What can you not have? What do you say, Connor? Zach? Hayden? Duncan? Sydney? Madeline? What do you guys say? What can we not have in a denominator? A negative. Good guess. What can we not divide by? Where do we get an error message in our... What do we... Yeah, so we can't divide by 0. If I take your favorite number, 25, whatever it is, okay? 66 divided by 0, you get an error message. You can't do that, okay? Can't take 66 things and divide it by 0. So when we're talking about domain, we had two things we talked about. Square roots can't be negative, so it's got to be greater than or equal to 0. And then denominators can't be 0. So this 3x plus 5 cannot be 0. So we solve. We subtract the 5 over. We get 3x cannot be negative 5. And then we divide. So x has got to be greater than or equal to 0. And we got to check the denominator. X cannot be negative 5/3. And then I can put my fancy bracket in. So I get x is greater than or equal to 0, and x cannot be -5 divided by 3 is what that says. And I can zoom in a little bit here. Questions, y'all? No questions. Last but not least is our value, f of g of 1. So we take f of x over g of x. We take this guy, and anywhere that you see x, I'm going to replace with a 1. So whatever this number is, normally there's an x there. Now I'm going to put 1 where the x is. Square root of 1 is 1. 3 times 1 is 3, plus 5 is 8. So we get our value 1/8. Final answer, f of g of 1 is 1 over 8. Plugging and chugging is pretty easy. Once you have done f over g of x or f plus g of x, then it's plug and chug, and it's pretty easy to do. When you do it, just please excuse my dear Aunt Sally rules. Do your exponents first and then multiply. How we doing, y'all? Give me a thumb. Give me a thumb. Where are we at? We're thumbs up. Thumbs up. All right, can I show you a couple more, and it'll be time to go. So I'm going to the back side. We got thumbs up. I got 2 new functions. It's asking us to do the exact same thing. I got f of x is 2x squared plus 3, and I got g of x is 4x cubed plus 1. So I'm going to bypass the plug and chugging stuff, okay? So if you got my notes, I'm going to skip over plugging stuff in. I'm just going to do f plus g of x, f minus g of x, and kind of go from there. So here we go. I'm doing f of x plus g of x. So now we have to do a little work. I've got f of x is, again, 2x squared plus 3 for this guy. And then g of x is 4x cubed plus 1. This is where I've got to add and subtract my like terms. So I go through. Normally we want you to write in descending order so the power of x gets smaller and smaller. So in this case, I would have a 4x cubed. I have a 2x squared. Those are unlike terms. I cannot combine them. They're like apples and oranges, so I keep them separate. But the 3 and the 1 we can add together. That's 4. So final answer is 4x cubed plus 2x squared plus 4. Okay. And then if I wanted to, I could find f plus g of 3 by plugging in 3 here and here. 3 here, 3 here. Do your exponents and then multiply. But for sake of time, I think you guys understand that. You guys have been plugging and chugging since Algebra 1. You can do that. Everybody gets this one right. Everybody, nobody ever misses this one on the test. It's this one. Why are people going to get this one wrong? F minus g of x. Yeah, buddy. Good job, Leo. Again, we're doing f of x minus g of x. Most common mistake, people write this, and then they go, oh yeah, minus 4x cubed plus 1. Well, they got that one right, but they get this one wrong. It's distributive property. We got to distribute. So very good. You're subtracting both of them. If there was 15 terms, you'd have to subtract all 15 terms. Positives turn into negatives. Negatives will turn into positives. So I go ahead and distribute. 2x squared plus 3 minus 4x cubed minus 1. So then my final answer is a negative 4x cubed, a positive 2x squared, and 3 minus 1 is 2. Okay, so final answer. And then if I wanted to, now I could do f of f minus g of 4, plug in 4 here and here. Please excuse my dear Aunt Sally, do your exponents. All right. Do we have any questions? All right, two more, then I'm done. Last thing, I didn't talk about domain yet. Domain with these two are the exact same, okay? So get your ears open for domain. Do you see any square roots? Do you see square roots? I see thumbs down. No square roots. Do you see any fractions? No. No square roots, no fractions, no restrictions. You can plug any number in here and you'll get a number back. So that means you can plug in anything you want for a domain. So your domain, all real numbers. So your domain for these two is all reals. There's no fractions, no square roots, no restrictions. You can use any number you want for x. Okay? So that's good. Hitting up on domain one more time. Let's finish up. Multiplication. I have f times g of x. That's just taking f of x times g of x. Now, the people that don't know what they're doing, they'll add in like an extra x here. Don't do that. Don't add in an x. All right? The x is for f of x, and that x is for g of x. Okay? So this is 2x squared plus 3. And then g of x is 4x cubed plus 1. The people that don't know what they're doing add in like an x there also. No, we're not doing that. Okay. Well, we got to take a binomial times a binomial. You guys know how to do that. What's 2 times 2? I'm getting 4. And what's that 4-letter F word you're allowed to say in math class? I'll give you the first letter. It's an F. You can say 4, yes. You can say 5. Ah, you the man, AG. All right, so we FOIL this thing. First outers, inners, last. 2x squared times 4x cubed. 2 times 4 is easy, that's 8. But what do you do with exponents when you multiply? What's x squared times x cubed? X to the... Yeah, again. Again, if you're not sure, go back to, well, what's x times x? That's x squared because we're adding exponents. All right? Outers and inners, I get a 2x squared and a 4. So I'll just write that 2x squared so I don't lose anybody. 3 times 4x cubed is a 12x cubed. And 3 times 1 is 3. Again, it might say right in descending order, so the power of x gets smaller and smaller. So final answer I should get 8x to the 5th plus 12x cubed plus 2x squared plus 3. It's about time to go, so last one I'm going to do lightning fast. F of x is 2x squared plus 3. G of x, 4x cubed plus 1. That's it. That's my function. That's f of x, that's g of x. Okay? The only issue you would have on this one is domain. Remember, your domain cannot be 0 for denominators. I would subtract 1. Almost done here. I would divide by 4. And then I would cube root. So my domain is a set of all real numbers, except x cannot be the cube root of negative 1/4. Woo! Ladies and gentlemen, chapter 2 on day 2 is over.